Okay, here's Pre-Calculus Online Lesson 1, Part 4. Should be the final video in discussing how to graph sine and cosine waves. And in this one, we're going to review the three transformations that we've already talked about: amplitude, midline, and period. And we're going to introduce the fourth and final transformation that's going to be a big deal in these things, and that one is called phase shift, which is a fancy word for horizontal shift, and slightly different from horizontal shifts. Horizontal shifts are what we talked about for sliding a function to the left or right when we were doing exponential and logarithmic functions. And they happen when you add or subtract inside the function. So for trig functions, we're going to call these things phase shifts because they're going to work just a little bit differently. I've talked before in the last video, especially with the last two examples I did in there, about where the function starts on the x-axis, where the function starts on the x-axis, and where it ends on the x-axis. So the start and the end point. The two examples I did in the last video, they started at 0 on the x because there was no horizontal shift. So they started at 0, and then they ended at the first period because that was the horizontal distance from 0. So now we're going to look at what happens when we shift this from side to side. And we're going to use the word phase shift instead of horizontal shift because we're not very interested in the total distance the thing shifts. These functions are periodic. They keep going forever and ever and ever and ever. So like shifting something by pi over 2 is going to be the same as shifting it in the other direction by 3 pi over 2 because these things repeat themselves. It's all just coterminal angles as far as the eye can see. Whoa, don't move that. So instead we're interested in where the function starts and where the function ends. And to clarify what I mean by that, I'm just going to throw myself into an example here. So probably the easy example we could do would be the sine of x minus pi over 2. So this is, if we're talking about this in terms of horizontal transformations, we would call this a shift to the right by pi over 2 units, which is fairly straightforward. And in this case, that's exactly what happens. We're going to take the sine wave. Normal sine wave does this to 2 pi. Here's pi. Here's pi over 2. Here's 3 pi over 2. This is going to shift it to the right by pi, so it's going to just be here. It's going to start at pi over 2, and it's going to end at 5 pi over 2, I guess. So, amplitude is still 1. Period is still 2 pi. It starts at 5 pi over 2, ends 2 pi units later. This distance is still 2 pi. That's the period. It just starts and ends in a different place. Where things are going to get weird is when we try to put a horizontal shift and an adjusted period into the same problem. And so for that, let's do an example. Y equals the sine of, let's say, 2x minus we'll go with pi over 2 again here. So here is, I have found, the very best way that you can think about phase shifts. Phase shift basically means where does the function start? And to find out where it starts, you're essentially asking, what makes the inside equal 0? This is the essential question being asked here. So if we come back to this example, the number, the x value that makes the inside of this thing 0 is pi over 2. If this is pi over 2 minus pi over 2, then the inside is 0, and you're looking at the sign of 0 when you plug in that x value. That's where the function starts. The function starts when you're taking the sine or the cosine of 0. So, x equals pi over 2 is what makes the inside 0. So pi over 2 is the phase shift, and it's the starting value. It's the first thing that I drew here. Pi over 2, that's where that starts. Here, if we want to find where this function starts, setting this inside fit equal to 0, it's going to be a little dicier. And honestly, the safest and easiest way to do this is always to take the insides, 2x minus pi over 2, this is what's inside the sine function, just set it equal to 0. Every time, just you can create this equation. It's always going to be a linear equation. It's going to be super easy to solve. This is the safe and reliable technique for finding your phase shift. So, we can start by adding pi over 2 to both sides. You get 2x equals pi over 2. Then you divide both sides by 2. And you get x equals pi over 4. And that's what makes phase shift different from horizontal shift. The horizontal shift here is pi over 2. But I'm not interested in horizontal shifts. For trig functions, I'm only interested in phase shifts, and the phase shift is a different number than pi over 2. It's pi over 4, because that's the x value that you can plug in here to make this whole thing equal 0. And when you're taking the sign of 0, that's when your function starts. So let's see what that looks like on a graph. The amplitude, I'm still doing this function here. The amplitude is 1, the midline is y equals 0. These things have not changed. These are still the defaults because there's no number here and there's no number here. The period is going to be 2 pi divided by this number. It's multiplying the x, so that's 2 pi over 2. So we'll get a period of pi. And the phase shift, I usually just abbreviate that p shift, like I abbreviate amplitude amp and midline mid. The p shift here is going to be, we already found that, it's pi over 4. So, we are now ready to graph this thing. The midline is y equals 0. It's convenient, it's right on the axis. And again, this is always where you start. Next step for me is thinking about the amplitude. From the midline, I'm going to go up to 1 at my peak, and I'm going to go down to -1 at my trough, or minimum. The next thing I will mark on this is the phase shift. This is the x value where the function starts. So I'll just put pi over 4 here. This is the starting point on this graph. The ending point, here's a very common mistake. Lots of people think the ending point is the period. It's not. The ending point is this distance past where you started. The ending point is the period plus the phase shift. So from this starting point, we have to go this distance to reach the ending point. And that'll leave us at 5 pi over 4. So we have our start, our end. The distance between those things is the period. That's pi. We have our midline through the middle. That's 0. We have the amplitude is 1. So this is part 3. This is part 4. So all I need to do now is draw a sine wave that connects these things. So I'm going to start. Sine waves start at the middle. They middle at the middle and they end at the middle, and in between they peak and then they trough. And that's it. If this had been a cosine wave, it would have started at the top, troughed, and then peaked again. That's how you can draw a sine, the graph of a sine or cosine wave based entirely on the amplitude, midline, period, and phase shift. So I'm going to do a couple more examples that involve all of these pieces working together to create cool looking graphs. If you need to pause or rewind to puzzle out what happened here, you have the power to do that. Okay, so I'm just going to create a new function. I'm going to stick with the sine wave for now. I'll do another example after this that'll be a cosine wave. Let's say I want to do no, it's time that we talked about, no it's not, we'll talk about that later. 2 sines of, I'll say, 3x plus pi minus 2. So this is a trig function with all 4 transformations being present and accounted for and doing weird things. So first thing that we should do is list them all out and figure what they are. The midline is y equals negative 2. The amplitude is 2. The p shift is going to be whatever x value makes this equal to 0. So let me work that out down here. 3x plus pi equals 0. 3x equals negative pi. If you subtract that from both sides, x equals negative pi over 3. If you divide by 3, so the phase shift is negative pi over 3. There's a shortcut for doing this if you're looking at the help me solve this function on your homework, or if you're looking at the show me an example. The book is probably going to tell you that the phase shift is always negative c divided by b, and if you are comfortable using that sort of shortcut, then go for it. I always get confused about which part c is. For this problem, c would be negative pi because c is always subtracted. You can play with that concept if you like. Again, I think the most reliable and the easiest and the most consistent way to find the phase shift is to take the bit on the inside and set it equal to 0. That's where this thing will start. And then the period is always 2 pi divided by this number. So the period is going to be 2 pi over 3 for this trig function. So this is all of the information that I need to start graphing. I'm going to start with the midline. Midline is at negative 2. Oh, I created these axes poorly. That's alright, I got an eraser. We can fix this problem. Okay. I forgot that my phase shift was negative and I needed to do things to the left of the y-axis. Okay, so midline is going to be negative 2. That's down here. Y equals negative 2. That's my midline. Done. Amplitude is going to be 2. So I know that wherever this thing goes, it's going to go up to 0 and down to negative 4. These are going to be the top and the bottom of my sine wave. 2 units above the midline, 2 units below the midline. That's my amplitude sorted. The phase shift is going to be negative pi over 3. That's where I'm going to start on the x-axis. And the period It's not where I'm going to end. I'm going to end at the phase shift plus the period. I need to go this period in distance from the starting point. So if I start at negative pi over 3 and I add 2 pi over 3, I should end at pi over 3. Oop. There we go. So the distance from the start to the end is the period. You can get your ending value. This equals the p shift plus the period. So now I just need to think about, I have sort of the bounds on my y-axis. It's going to go between 0 and negative 4. I have sort of the bounds on my x-axis. It's going to go from negative pi over 3 to pi over 3. So that the sort of box that I'm working in is defined. Now I just need to figure out where it starts, ends, and middles. Sine waves start in the middle, they middle in the middle, and they end in the middle, vertically. And then in between that, it will go up and down and back up. So this is the graph of 2 sine of the quantity 3x plus pi minus 2. Looks like this. I'm going to do another example. Okay. One more example. I'm going to do an example using cosines so that we can see what that looks like. So let's say y equals cosine of 1/2 x minus pi over 4 plus 3. Step 1, as always, identify all of the pieces that you're working with and write them down. Here the amplitude is not present, means the amplitude is 1. This is the default. The midline is going to be y equals 3. The p shift is whatever makes this piece equal 0, so I'll do that down here. 1/2 x minus pi over 4 equals 0, so 1/2 x equals pi over 4, and then x equals, multiply both sides by 2, x equals pi over 2. That's my phase shift. And then the period will be 2 pi divided by this number that multiplies x. Dividing by 1/2 is the same as multiplying by 2, so I'm going to get 4 pi as my period. So, this is all the information I need to construct a graph. I will make some axes. And I will start with the midline. Midline is 3. There's the line y equals 3. Amplitude is 1. So I'll go up to 4, down to 2. The phase shift is pi over 2. So that'll happen right here. This is my start on the x-axis. The period is 4 pi. So that is the distance from the phase shift that I need to travel before I get to the end. Start equals p shift. The end is the p shift plus period. Pi over 2 plus 4 pi looks like it's going to be 9 pi over 2. So I have my boundaries for one period on the x. I have my boundaries for one period on the y. I just need to think about where I am starting and middling and finishing. Cosine starts at its peak, ends at its peak, middles at its trough, and does the wave thing in between that. So that's a cosine wave with all the various and sundry transformations involved. There's one more big thing that I need to talk about in terms of graphing sine and cosine waves. That is, what do we do with this? This -3 out front. Let's talk about this. We'll start with the midline is y equals 1. Then we'll talk about an amplitude. The amplitude, it's very tempting to say that the amplitude should be -3, because in every other example we've done, the amplitude has just been whatever this number is. But in video number 3, I think, it's been too long now, I don't remember. In video number 3, I defined amplitude right at the start. And when I defined it, the definition is not whatever number is out front. The definition of amplitude is the distance from the middle to the peak. And that distance is not -3. That distance is +3. So that's kind of what's funny about an amplitude here. The amplitude isn't just this number. The amplitude is always the absolute value of this number. Then we'll talk about a p-shift. Phase shift is whatever makes this 0. 2x minus pi over 2 equals 0. So 2x equals pi over 2, x equals pi over 4. Is that the exact same one I did last time? It is, isn't it? Huh. Turns out I'm not very creative. That's what I get for making these up on the fly and not planning anything. So, pi over 2, still our phase shift. No, last time I did something with fractions. I'm good. I don't know what's going on anymore. Too much videotaping. Period is always going to be 2 pi divided by this number. Just going to just look like pi. Yeah, the last one had a period of like 4 pi or something. We're good. We're all set. This is new. It's original. So, this is all taken care of. And what's a little weird is that none of this information reflects the fact that I have a negative sign attached to this 3 in this function. So, honestly, this negative sign isn't going to affect much until the very end. So let's just proceed like normal for now, and we'll deal with the negative sign later. I need some axes. The midline is y equals 1. I drew that bad, didn't I? Okay, y equals 1 is the midline. That's the first thing I'm going to draw. Second thing I'm going to draw is the amplitude. It's going to go 3 units above this to 4. It's going to go 1, 2, 3 units below this down to -2. The phase shift is pi over 2. That's where I'll start. I'll end 1 period distance later. So the period is pi. Oh, this is pi over 2, then that probably happens right here. Okay. 3 pi over 2. Close enough. So this is, again, this is the start, is the P shift, and the end is the P shift plus 1 period. So I have the horizontal range of my thing, I have the vertical range of my thing. We need to talk about what a sine function does. Generally speaking, a sine function will always start in the middle, it'll end at the middle, and it will middle in the middle, and then in between it'll go up and down and back up. Unfortunately, this is not a standard sine function. This is a negative sine function. It's still going to start middle and end in the middle, on the midline. Those things won't change. But instead of starting by going up, it's going to start by going down. If it were positive 3 here, then it would be flipped upside down. We would start by going up and down, then up again, like a normal sine wave. This negative sign is just going to flip the whole thing upside down, just like the negative signs out front always have done. That's just how sine functions and upside down flips work. We're already at 26 minutes in, so let me wrap this up with a checklist of things to do. When you are confronted with a function that looks like a sine bx plus c